So how do we find probabilities for a normal distribution? The instruction how to use our calculator are given on page 1. Second, normal CDF, lower bound, upper bound. If we are using a very small number on the left-hand side, we use negative sign, 1, second, exponent, 99, and if you want to use a different number like negative 1,000 or negative 100, that's also fine. For a positive infinity, a very large positive number as upper bound on the right-hand side, we can use 1, second, the exponent, 9, and the 9. Or equivalent to that, you can use 100, 1,000, or any large number. Let's take a look at one example. This example says, a survey, it means that we have a sample, indicates that people keep their cell phone an average of 1.5 years before buying a new one. An average 1.5 years. So the mean is given to us. The standard deviation is 0.25 years. This is our standard deviation. Well, a cell phone user is selected at random. Find the probability that the user will keep his or her current phone for less than 1 year before buying a new one. And assume that you have a normal distribution. So what are we looking for? We're looking for the probability that our X is less than 1 year. The continuous random variable is less than 1 year. Less than. Well, let's take a look at our normal distribution. This is our normal distribution, and here we have mean, which is 1.5. 1.5 is in the middle, and standard deviation is 0.25. Very well. So this is our mean, and on the horizontal axis, we have our X values. This is just the standard, this is just a normal distribution. It's not a standard normal distribution. Remember that for a standard normal distribution, we need to have a z, and you have 0, 1, 2, 3, -1, -2, -2. This is different from a standard normal distribution. Perfect. So what do we have here? We have a normal distribution and less than 1. 1 year, less than 1 year is going to be this area or this probability on the left-hand side of 1. We want to find this area or probability. What is this area? What is this probability? Probability of X less than 1 is this green area. How do we find this green area? Well, we have our calculator and we want to use our calculator. Turn on your calculator. Second, vars, find normal CDF. So second vars and normal CEF. What is the lower bound? Take a look at the graph. We are finding this area. So the lower bound is a small number on the left-hand side. It's a negative number on the left-hand side. But what is that negative number? We can use a lower bound like negative 100 or negative 1,000. Our upper bound, this number stops here. So again, we want to find this green area. The lower bound is a very small negative number, and our upper bound is 1. So 1. What is the mean? The mean of the data is 1.5. 1.5. What is the standard deviation? 0.25. Okay. The probability is almost 2%. The probability is 0.022 or just 2%. This probability is roughly 2%. As you can see, this area is a very small portion of the area below the graph. It's a very small portion. So our lower bound, let's write these down. Negative 100, negative 1,000. Our upper bound is 1, and the mean as given to us 1.5 years, and the standard deviation as given to us as 0.25. You might say, hey, why not using standard normal distribution? If we want to use the standard normal distribution, if we want to use Z values, we need to convert this X into Z first. We need to convert X into Z. Remember that Z was X minus mean divided by standard deviation. So Z is equal to X is 1, 1 minus mean is 1.5 divided by standard deviation, 0.25. Negative 0.5 divided by 0.25. So in this case, our Z is equal to -2. So -2, let us locate -2, and as you can see, it's less than -2. So we're looking for this area to the left-hand side of -2. Well, if you want to use our calculator, the instruction is exactly the same, except for mean and standard deviation and your upper bound. So we go to our calculator, second vars, we find normal CDF. Our lower bound, again, it can be a negative number, negative 1,000, negative 100. Your upper bound is now -2. So for minus sign, -2. The mean of standard normal distribution is 0, and the standard deviation is equal to 1. So here you get the exact same probability, almost 2%. So we can use either X or we can use Z. It gives us the exact same outcome. So in this case, our lower bound, again, negative 100, negative 1,000. Our upper bound is -2 because we're finding the probability that Z is less than -2. It was X. If we want to keep the original data, we use X. If we want to convert that into standard normal distribution, we use Z. And here, the mean of a standard normal distribution is 0, and the standard deviation of standard normal distribution is 1. And as you saw, the area is almost 2%. Let's go over another example together. On page 2, we have this example. The example says, well, a survey indicates that for each trip to a supermarket, a shopper spends an average of 45 minutes. So the mean is given to us, and the standard deviation is 12 minutes. So these are our X values related to our original data, or X values. The length of time spent in the store are normally distributed and are represented by variable X. A shopper enters the store A. Find the probability that the shopper will be in the store for each interval of time listed below. B. Interpret your answer when you have 200 shoppers enter the store. How many shoppers would you expect to be in the store for each interval of time? The first interval between 24 and 54 minutes. So what's the meaning of that? It means that find the probability that your X is in between 24 minutes and 54 minutes. So we're lucky in this case. Why is that? Because our lower bound and upper bound are given to us. This is our lower and this is our upper bound. Well, these are X values, so our horizontal axis has X values. We're not working with the standard normal distribution. We're not working with our Z values. Of course, we can convert each of these into Z and use our standard normal distribution. But since we have X, we can directly use our X values. So 24, let's take a look at it. Find 24 minutes and 54 minutes. So we want to find this probability or this area. What is this area? What is this probability? This is the probability that X is in between 24 and 54. What is this probability? Calculator to the rescue. So second vars, normal CDF. So write all the steps. Second vars, normal CDF. So our lower bound is given, our lower bound 24. So here we have 24. Our upper bound is given to us as 54. 54. Mean, what is the mean? Mean is given to us as 45 minutes. So mean is 45 minutes. And the standard deviation is 12 minutes. We have all the information, and then the probability is almost 73%. So this is almost 73.3%. So the probability that that shopper spends between 24 to 54 minutes in the store is 73%. Again, note that you can also convert that into Z, is X values to Z values, and use Z scores. We get the exact same result. Well, part B of the question says, what if you have 200 shoppers all at the same time in the store? We know that the probability is 73.3% with 200 shoppers in the store. The probability is 73.3% times 200, which is approximately 147 shoppers in the store. Shoppers in the store who spend between 24 to 54 minutes in the store. Next one, more than 39 minutes. Okay, so we want to find the probability that X is more than 39 minutes. What is this probability? More than 39 minutes. 39 minutes, okay, we have our lower bound. More than, it means that 39 minutes or more, 40 minutes, 45 minutes, 50 minutes, 60 minutes, and more. So we're looking for this area for this probability. P of X greater than 39 minutes. What is this? So as you can see, your lower bound is given. Your lower bound is 39 minutes, and your upper bound is a positive large number. Use our calculator. Second, VARs. We find the normal CDF. Normal CDF. Okay, our lower bound is 39 minutes. So 39 minutes. Our upper bound, it goes to a positive number. You can use 100, 1,000, or a large positive number. What is the mean? Mean of the data, as you can see, is 45 minutes with standard deviation 12 minutes. The same mean and standard deviation that you used for question 1. 45 minutes and standard deviation is 12 minutes. So what's the probability? The probability for one shopper is 69.1%. So this probability is 69.1%. What if you have 200 shoppers at the same time in the store? So here you have 69.1% times 200, which is approximately 138 shoppers spending more than 39 minutes in the store. Shoppers in the store who spend more than 39 minutes in the store.